Right. Just to make sure again, can you see the board, guys, and hear my voice clearly? Hello, can you see my board and hear my voice clearly? Yes, Sada?
Yes. Yes.
Okay. Today we will go through the final revision for paper 4. I'm not sure about tomorrow. If you have doubts, you can send me directly through WhatsApp or through the chatting room. And today we will go through one of the papers, which is February, March, even if it was recorded before. But I think when we go it step by step, through it step by step, so we're going to solve it and we could explain the entire syllabus through this paper. This is number 2. Number 1, my advisors are going to use my board right now to write all those that you need to know before you go to the exam hall the day after tomorrow. So I will use the board right now. Please write with me. This is just a kind of refreshment for your information about O-level laws. I'm going to explain to you right now, step by step, the syllabus from the beginning to the end, from the first law to the last law that we need to know before we go to the exam hall. So number 1, we will do the explanation for the laws for O-level or IGCSE. Then we will start the paper. I'm not expecting we could finish in 2 hours. Maybe it could take a little longer. So keep in mind that. خلينا نبتدي. Any question before I start? Any point? It's not clear that much in the syllabus before I start from the beginning to the end. حد عنده سؤال؟ متأكدين؟ طيب anyway خلينا نشوف يا اولاد. The first chapter in our syllabus, it was about measurements, and we speak about measurements many times in paper 6 in our revision for paper 6, and we said how to do this some measurements. There is no measurements in paper 4. They will not ask you to do any measurements. This is most probably could happen. But in sometimes you need to take the readings, like what's the reading of a vernier, what's the reading of a ruler, what's the reading of voltmeter or a meter or something very similar to paper 6, but it's not that much in paper 4. Let's start with the first part in our syllabus about laws or calculations, اللي هو كان لو تفتكروا motion, when it comes to motion. To study that, it was like the first law about motion that we studied was very easy, like the speed. This is when it comes to motion. We said that on a speed equal to distance divided by time. This is the first law that you need to understand. Even I could use the law to find the definition, like speed, it is the distance covered during the unit of time. This is the way in physics how to find the definition. Like speed, it's that number if the denominator was 1. So I'm going to write speed, it's distance when time is 1. That's why we say it in one sentence. Speed, it is the distance covered by a moving object during the unit of time. And we know that the unit of time is just 1 second when it comes to a SI system. So I'm going to write here speed, it is the distance divided by the unit of time, or it is the rate of changing in distance. So the idea of rate here, it means they related to time. That was the first law. The second law here, but I have a condition here, guys, the condition required, so I allowed to use this law if the acceleration is 0. But if the acceleration was not 0, it means we have no specific speed. So there is no constant speed, as we said before. So if the speed is variable, so we have an acceleration, or the acceleration is not equal to 0. In this case, we need to use some other laws, like the acceleration does not 0. So in this case, I'm going to use the equations of motion, which were like the velocity final equal to the velocity initial plus AT. Remember, v is final velocity, u it's the initial velocity, a is the acceleration, t is the time. The second law is, I will not go through the proving of that, but there is another law which is the displacement equal to the average velocity. If I say displacement equal to speed times time, so I'm gonna say here it's v, but it's average times time. So when it comes to the idea of the average here, I can write the displacement or distance. I don't care about vectors right now in that moment. So the displacement equal to v plus u divided by 2. This is the average velocity. The average between any two numbers, it could be, you just need to add them, then divided by 2 times t. And that was the second equation of motion, if we consider this one is the first equation. The third equation is, instead of using this v, I'm going to use something else. I'm going to substitute the value of v in equation 1. So I remove this v and I put u plus at. And we're going to have another law, which is, the displacement. This is not speed, by the way. This is displacement equal to ut plus half at squared. Remember, in u, it is the initial speed. T is the time. Half is a constant number. It reflects to the idea of the average. And a here is the acceleration. T is the same time that we have here, right? That was the third equation. And very, very few cases, they ask you about the fourth equation, which was the velocity square equal to u square plus 2as. So if you observe the difference between these laws are, in the first equation, as you see here, we have no displacement. So if I have some given, and I have a question about this v or u or a or t, I can use equation number 1, but under one condition, which is I have no displacement. But if I have the displacement or I need the displacement, I can use the second equation. But remember, in equation 2, we do not have the difference between them. We don't have acceleration. In the third equation, we have an acceleration, we have a displacement, we have initial velocity, but we don't have final velocity here in such this equation. So if you need the final velocity, you cannot use this one. It depends on the given. And in this equation, I have the final velocity, the initial velocity, and the acceleration and the displacement, but there is no presence for the time here, right? So all these equations consider one equation, but it depends on what you need. It depends on what is the idea of the problem that you have. Like if you need to find the displacement, you can use this one if you know the other variables. That was the first part of equations regarding to the motion. Then later on, after the equations, we study something regarding to Newton's laws. We have 3 Newtons done by, we have 3 laws done by Newton. So here we have Newton's laws. The first law was like this in math means summation, or the total of any force acting on anybody equals 0 under one of these conditions. If the body was exactly at rest, so if the body was not in motion, not rotating, it means it's exactly at rest. There is no rotation, there is no motion, it's not moving forward or backward, or even there is no vibration, there is no rotation. So if that happens, it means the total force acting in the body is 0. And we have another condition, it may be available, like if the velocity of the body equal 0. So if the velocity of the body again equals 0, it means, the acceleration here, the body is at rest, or the velocity is constant. So here at rest, it means the velocity is equal to 0, and here the velocity is constant. If the velocity is constant, it means the acceleration is 0. There is no change in the acceleration. Like if you back to the equations of motion here, like this one, if both are equal, it means this value is 0, and actually the time cannot be equal 0. because you cannot stop the time. So if that value means 0, it means the acceleration is 0. That's why, because v equal to u. And this is what we mean here. The acceleration is 0 in case if the velocity is constant, right? And in this case, the total force acting in the body was 0. That was the first law of Newton. The second law of Newton, he said, any force to be calculated, it should be mass times acceleration. Like if we have a moving object, so its mass times its acceleration is going to give you the force accelerating the body. So if the body was accelerating, so it means the force accelerating the body equal its mass times its acceleration. So imagine, we have a body is moving with a constant velocity. We have a mass, but we have an acceleration equal 0. So mass times 0, whatever the mass is, so the resultant will be 0. And this will take us back to equation number 1, or the first law. Even if the body is moving with a very, very constant speed, even if it was very fast speed or very high speed, it means, if it was constant, it means the acceleration still 0 and the total force acting in the body is still 0. But remember, keep in mind, you cannot say, for example, you cannot say, the body is moving and there are no forces. There is some forces, but the total of them is 0. Like I have a forward force and I have a backward force. These two forces are equal, so the total is 0. But you cannot say, there is no force acting. No, there is some forces acting. That was the first law. This is the second law. The third law, they said, the force acting over anybody, it could look like action equal reaction. So if I have two objects acting over each other, the force from the first object, it could equal to the force from the second object, but they are opposite in direction. Like the force here is forward and the force in that side is backward. It gives you an example, very common example, like if we have a table and over the table we have an object, there is a common force acting over this object right now. It's the weight acting down. So I'm going to say Fg here. This is the force of gravity acting down. And there is a normal force from the table acting over the body up. And I can say if that was the normal force, so this force equal that force in magnitude, but they are different in direction. That's why one of them is positive and the other is negative. Keep in mind, we need, or two objects are required. Here we have a body and we have a table. There are two objects acting over each other. This is what I could say. That was the first law and the second law and the third law of Newton. And we will see that, I think, in the paper that we have today when we solve it together. The equations of motion, the equation for the forces here. Then we still have something related to the density. In the second chapter, we were studying density, and this is very, very old information. We know the density of anybody, it has a symbol which is rho, and any density or anybody has a density equal its mass over volume. That's why when we explain that, I could say, the density, it's not a mass, the density, it's not even a volume, it's the ratio between them. And this is what decided if the body will float over liquid or sink through the liquid itself. Like if the ratio here is less than the ratio or the compatible ratio in the liquid, it means the body is light. So the body will float over the surface. If that ratio is higher than the ratio comparing by water, so the body will sink in water. Like I have two constant numbers here, you need to memorize them. It's not usually mentioned in the question. Like the density of water, density of H2O, we have two numbers. The first one is, I'm not sure if you see that or not. The density of water is 1,000 kilogram per meter cube. Remember, the density, it's the mass over volume. So the mass in kilograms, the volume in meter cube. And this is a constant number for the water if it was perfectly pure. But if it was impure, like there is some salts, like most of the water that we have, there is some salts dissolved, so the density will increase a little bit. Like it could be upgraded to 1080 or 1090. if there is some salt inside it. And also we have another number, which is the density of water, which is H2O. And sometimes instead of using kilogram for mass and meter cube for volume, we could write it's just 1 gram per centimeter cube. Remember, if we change 1,000 kilogram to grams, it means 1,000 should be times another 1,000. So I have 1 million, then divided by, when I change meter to centimeter, divided by 100, but this is power 3, so it could be again divided by mega. So if it was divided by mega, it gives you the same answer. So 1 million divided by 1 mega, or 1 million divided by 1 million, it gives you 1 gram per centimeter cube. And this is the density of water. Is there something wrong in... Oh yeah, someone. Okay, guys, just to make sure, can you still hear my voice clearly and see the board?
Yes.
Okay, fine. I'm gonna erase the board right now to take the other part of the equations that we still need to know. So the next part here, it could be about pressure, then energy, then heat energy, and so on. Then waves, electricity, electromagnetism, and finally, if we have some laws for radioactivity. That was the first part.
Mr. Will we solve today or no?
Yes, yes. Just when I express these laws, we're gonna start complete past papers together. We're gonna finish it. ماشي علي؟ ماشي رئيس؟
Okay, Mr. Will we solve the February March or no?
Yes. And we will take some time because we're gonna explain it in more details to make it enough for the rest of the syllabus. Right, let's see. The second group, it was about pressure. I have many laws for pressure, but the main idea is definition of pressure itself comes through this law. Pressure, it is a concept in physics, means force acting over the unit of area. I said the definition as usual. P is F when A is 1. So P is F when A is 1. So if the denominator is 1, force divided by 1, it gives you force. So the pressure is the force under one condition, which is if the area was equal to the unit. This is usually happening. Pressure, it is the force acting over the unit of area. Remember, the force here, according to SI, it's measured by Newton. The area here, according to SI, measured by meter square. If Newton per meter square, you can write Newton per meter square or Newton meter minus 2. Like I can write it Newton per meter square or Newton meter minus 2. Or instead of both, you can write PA, it means Pascal. But if the idea of Pascal here, if the measuring unit was not meter square, if it was centimeter, for example, you cannot write Pascal here. Pascal only, it gives you an idea about the force measured in Newton and the area measured in meter square. Otherwise, you cannot write Pascal if it was in something else or some other measuring unit. And through this law also, we could reach to another law, which is pressure. If you remember, pressure equal rho G H. This is usually we used it for liquids, but it could work for any body if you just know the height and the gravity acceleration and the density of that liquid or the density of that body. It could work. Pressure equal rho GH and pressure equal force divided by area, both are working. This is when it comes to pressure. After pressure, we study something related to energy, and we said the energy potential, it's mgh. M is the mass, G is the gravity acceleration, H is the height. And remember, the energy kinetic or the kinetic energy, it's have mv squared. Remember, V here, it's the final velocity or the average velocity. It cannot be only initial. This is not initial, this is final velocity or the average velocity if the velocity was variable. And m, it is the mass of a moving object, have is a constant number, and these two laws, we could use them to find the energy of object. This is the potential energy, energy gained by the body due to its position, and this is the kinetic energy, energy gained by the body due to its motion. This is the second law. Then after that, we studied something related to the work, and we said in the work or energy, energy is work, work is energy, and the work equal force times displacement. Here we have a condition. Let me just allow this guy to be in. So I can write into the work equal force times displacement, but here there is some conditions we need to care about it. This condition is, the force and the displacement should be parallel or acting in the same direction. Otherwise, there is no work. Right? So I could say here in the work, it is force times displacement. And here we have a condition, which is, the force should be parallel to the displacement. Like, this is just a quick example. If we have an object, this object could be affected by a total resultant force equal to F1. And due to that force, the body will move from location A to location B across distance equal 3 meters, for example. You could write here 3.0, but anyway. So depending on that, I could say, the work equal 3 times F, right? Because as you observe, the force is acting to the right and the body is moving to the right, to the same direction of the force effect. This is the idea of the work. But to avoid confusing between moment, for example, when I say moment, I don't care if it was clockwise or anti-clockwise right now, but the moment itself, again, it's equal force times displacement. But remember, that F and that displacement, they are not equal. They are not acting in the same direction. The angle between them should be 90 degrees. We said that many times before. And they are, looks like opposite. Force times displacement, they're supposed to be parallel. Otherwise, there is no work. Here, force times displacement, they're supposed to be 90 degrees between them. Otherwise, there is no moment. If they were parallel, there is no moment. And here, if the angle is 90, there is no work. Remember that fine when you study for your exam. So this is the difference between the normal work and moment, right? The idea of moment. Then after moment, we said something about momentum. And we said, from now on, when I ask you what's meant by force, you could say it is the rate of change in momentum, right? So please stop saying it's push or pull. This is not the force anymore. The force, or the definition of force, it is the rate of change in momentum. Let me write that down here. The momentum, it is the mass of a moving object times its velocity, right? So if the body was moving, it has a specific velocity. In a specific time, it has a velocity. So when I say the momentum, it is the mass times the velocity. So the momentum in a specific time, it is the mass times the velocity in that time. So when it comes to the force, again, I could say that, the force, it is the change in momentum. By the way, momentum, it has a symbol, which is P. So I could write change in momentum divided by time. If you continue that, change in momentum means mass, change in velocity, because the mass cannot be changed easily, divided by the time. These two laws are exactly the same. Momentum, change in momentum divided by time, it gives you the force. And it means, force could be change in momentum divided by time, change in V divided by time. From the equation of motion, it gives you the acceleration. M, it's the mass. So this is the second law of Newton that we just wrote it over here. So whatever you like it or not, but there is no conflict at all in physics, right? So this here, when we speak about momentum, so the rate of change in momentum, it means M delta V divided by T, it gives you mass times acceleration. This is the definition of force. And we have one single point here I want to announce about. And sometimes they ask you about very, very little point. If you do cross multiplication, like F times T, it gives you delta V. So I'm going to write here delta V equal force times time. And this concept, it has a name, which is impulse. So when I ask you what's the impulse of any object, it means the force acting over the object times the time, which was this force acting on the object through. And it's exactly the same idea of change in momentum. So change in momentum is the impulse. Impulse is change in momentum. This is what you need to know regarding to this part. After this part, we speak about something related to, we explain it through the year, related to the law of pressure, especially when it gases. We just have one simple law here, which is pressure V, pressure times volume divided by the temperature equal to pressure times volume divided by temperature. So here we have a case, specific temperature, pressure and volume. If it was pressure 1, volume 1, time, temperature 1, it could equal to pressure 2, volume 2, temperature 2. So here we have a position for the gas, and here we have another position for the gas, right? So whenever they ask you, like, if they said the temperature is constant, just remove this temperature, because if it was constant, so they will cancel each other. And the law will be changed, V1, V1 equal V2, V2. If they said the volume of the two amount of gases constant, just remove volume, because they are constant, it means they are equal, so they can cancel each other, and so on. And remember one very important note here, that temperature in Kelvin, it's not in degrees Celsius, because this is a real temperature. It's not a change in temperature. Is it clear, ya Sada? I have finished.
Mister, can you repeat this part?
Which part? I said in this law, the pressure of the gas and the volume of the gas divided by the temperature of the gas equal the new pressure times the new volume divided by the temperature if the temperature changes. Because if I change one of them, the rest will be changed to keep the fraction constant. Remember, that T should be in Kelvin, not in degrees Celsius. Best, because this is not a change in temperature, it is a temperature. Like when I tell you, we have amount of gas in 23 degrees Celsius, you cannot consider 23 in this law. You cannot enhance 23 degrees Celsius in this law. You need to change it into Kelvin. Mashi?
Okay, Mister.
How can I change it into Kelvin? You remind me. And now the degree in Kelvin equal the same degree in Celsius. Don't say degree for Kelvin. The temperature in Kelvin equal degree in Celsius, but should be plus 273. 0.15, but don't worry about 0.15 here. We will not ask you about it. If it was degrees Celsius, it's equal to the temperature in Kelvin, but subtract 273.15. So this law, it allows you to change from degrees Celsius to Kelvin or from Kelvin to degrees Celsius. So most probably you could use this one if I give you the temperature in such this problem in degrees Celsius. So you need to change it into Kelvin. Is it clear, ya bunay? Khalas, I have finished this part for the pressure. After pressure, we reach to something like regarding to heat energy. Let me write them. I need to clean the board, ya walad. Can I? Can I, ya bashmantsi?
Yes.
Yes.
Okay. So what we need to do right now is for heat energy, I could say that, like, we start this heat capacity. heat capacity. Heat capacity equal to, it's the amount of heat energy needed to change the temperature of the body by 1 degree Celsius or 1 Kelvin. Both are the same because this is change in temperature. Look at this example. If I have 20 degrees Celsius, change to be 21 degrees Celsius. It means in Kelvin, when I change this number into Kelvin, it means 293 Kelvin could be changed to new 294 Kelvin. So the change in temperature here is 1. The change in temperature here is still 1. That's why I could say, it's the amount of energy divided by delta T. This delta T, if it was degrees Celsius or Kelvin, it doesn't make any difference for us because this is not a real temperature. This is a change in temperature. Right. That was the first law, just remind that. Then after heat capacity or thermal capacity, we have specific heat capacity, and we said it's Q divided by delta T as it is, but this is for specific mass, which is the unit of mass. This is for the body, and this is for the unit of mass. This is for the entire body, whatever the mass is, I don't care, but this is for 1 kilogram of the body. Then later on, we said something related to latent heat. And we said latent heat of fusion or of vaporization is the amount of energy needed to change the state of the body from to. It depends on the concept. If it was fusion, from solid to liquid. If it was vaporization, from liquid to gas. So I'm going to say here, this is the amount of energy needed to change the state of the body, of 1 kilogram of the body. But the temperature during this change in state should stay constant. So I will not mention the temperature here because it's constant. Then I'm going to divide it by M. Look at the difference between the three laws. They are very specific. Q divided by delta T, Q divided by M delta T, Q divided by M. Heat capacity or thermal capacity, specific heat capacity, latent heat of fusion or latent heat of vaporization or specific latent heat. Even the word specific here, it's correct because we have all mass here. We have the mass here, right? It stays specific if you wish. That was the law. And also we can use this law to do cross multiplication. I'm going to give you the amount of heat energy gain or lost equal to MC delta T. I just did cross multiplication. So Q equals C M delta T or MC delta T, right? One more observation here. We will mention that even in electricity in a few minutes, that Q, it's energy. And I know energy means power times time. So this P here means power times time. And in electricity, the power itself could be calculated by potential difference times the current, still times the time, still equal MC delta T. I have 2 letter T here, so I'm going to write here, this T is the time, should be in seconds, but that delta T means change in temperature. I hope that's clear. They are totally different. This T is the time, and this delta T means the change in temperature. This is also, we used it for many problems, and we have in the paper for today, we have another problem. We could go through it to see how it looks like, or how can we use this. Then after that, we reach to waves. In waves, we have some specific laws we could use, like after some definitions, I'm going to send you a paper that contains all definitions, and I did already in WhatsApp before. But remember, in waves, we have some laws like frequency. It is the number of waves divided by the time needed to make them. If I have 10 oscillations happening in 1 minute, it means 10 divided by 60. The time here should be in seconds. If you flip the frequency, you will get the periodic time. So the periodic time, it is the time needed to make one wave. So it could be the time over the number of waves. through these two laws, I can say that in a frequency equal 1 over t, or t equal 1 over frequency. So this is the relation between them. If I have the periodic time, I could find the frequency. If I have the frequency, I could find the periodic time if you use this law. If you have the number of waves and the time needed to make this number of waves, you can find both frequency or periodic time. This is what we study here. And also we have another law, which is the velocity of the wave equal to frequency times wavelength. So the velocity of any wave equal to the frequency of that wave times the wavelength of the wave itself. So this is also one common law we could use in waves. I think there is nothing more in waves, unless if we go to lenses or mirrors. And mirrors, we have another 3 more laws. Again, guys, can I erase the board? تكونوا ما بتكتبوش وراي.
مستر معلش هو T هنا ايه؟ The second one. Yes.
This is the periodic time and this is the total time. Example, if I have one rotation could happen in 1 second. It means the periodic time is 1 second. But when I do 3 rotations, so the total time is 3 seconds.
3 seconds. Okay.
So T here the total time, but T capital here it is the periodic time. This is what I mean by T capital. خلاص امس اوعى تكونوا ما بتكتبوش يا اولاد القوانين، لازم تكتب عشان تنشط اللي في دماغك حبيبي. امسح خلصنا؟
Yes.
خلينا نروح نشوف 3 more laws for waves. The first law is when I say the velocity of the wave, for example, in air divided by the velocity in any medium could equal to the sine divided by sine. This is when it comes to refraction. If I have 2 different mediums, sine, this angle is the angle in air, and this angle is the angle in that medium. For example, if that was air, and this is, for example, glass, and here we have a normal, there is an angle here, and there is another angle down here. As you observe, because the ray will transfer from air to another medium, so it could refract to be closer to the normal here. This is what we call normal. So the angle here is much bigger comparing by the angle in glass. So I'm gonna write here sine, the angle in air, theta in air, divided by theta on the other medium. And you know the angle in air, it should be much bigger comparing by the angle in medium. And that's why the speed in air is much bigger than the speed in any other medium, right? This is what I mean by V air or V in air divided by V in medium. This is sine theta in air or sine theta in that medium divided by that. If we flip the fraction, it's going to give you the same idea, but this 2 fractions, it gives you a constant number, which is refractive index. And the refractive index itself, it has no measuring unit. We said that before. That was one of the great laws. Even I can use the idea of n, I mean refractive index equal 1 over sine c. C is the critical angle. The angle is the minimum angle that its refracted angle equal 90. And you know sine 90 is 1, so that's why I wrote 1 here. It's the same law, but I use sine, the angle here was 90, the angle in air was 90, and the incident angle in the massive medium was C. So the critical angle could be calculated using this law, right? So I can continue the equation to find the critical angle equal sine minus 1 for 1 over n. N is the refractive index. Remember, your calculator should be in degrees, not in rad. Make sure that in your calculator there is a very, very small d at the top of the screen, not in rad. Otherwise, you will get another answer which is wrong. Right? And also, there is one law done by Snell. He said, if we have a reflecting surface, the angle of incident should equal the angle of reflection. So if we have a normal here, this angle, which is I, should equal the other angle, which is R. Right? This is also, we mentioned that, and we have some problems. But I think this is mainly in paper 6, but there is some problems in paper 2 that is coming in the future, and paper 4, you may use this, this angle equal this angle. This is what we call Snell law. The last point that I need to explain for today before we start the complete papers is the group of laws about electricity. I need to just write them in one page in front of you to just remind you by the laws of electricity. I need to clean the board again. Can I? If you finish, please let me know.
Yes. Yes.
The last track in our explanation today, before we start the complete paper, I just need to write all laws about electricity. Please write that with me. Refresh your mind with electricity, because to be honest, paper 4 fell with questions about electricity and electromagnetism. There is not that much laws in electromagnetism, maybe next year, but for electricity, we have a bunch of laws. Let's start with the beginning. The first law in electricity that you need to know is the potential difference. It is the energy needed to transfer the unit of charge over the circuit. So here, this is Q. Measuring unit, potential difference measured in volt, has a symbol which is V. E here is the energy. Q here, it is the charge. The measuring unit, charge measured in coulomb, energy measured in joules. V means volt, and actually this is the voltage. And sometimes we can write it as just V, right? That was the first law. The second law was about current. And here in I mean the current, it is the amount of charge, it's the same Q that we have here, passing through the circuit in just 1 second. So I'm going to be divided by time. Remember, the Q measured in coulombs, T measured in seconds, and the current measured in coulomb per second, or you can write ampere or A capital, right? The second law done by Ohm, he said, the potential difference also could be calculated by the current passing through resistance. So the total current in the circuit times the total resistance in the circuit, it could be calculated. If you say I times R, it gives you the total potential difference in the circuit. And also we have another law here, which is the resistance of any circuit could equal to resistivity. I mean, the resistance of any wire equal to the resistivity of that wire times the length of the wire divided by the cross-sectional area of the wire. Remember, rho L, the cross-sectional area of any wire must probably, it looks like a circle. If it was look like a normal wires, the cross-sectional areas looks like a circle, and the area of the circle could be calculated by R squared, right? And also we have a bunch of questions here in the revision worksheet regarding to this. Later on, how to find the total resistance. R, if it was series, could be calculated by R1 plus R2 plus R3 plus whatever, how many R's that you have. If it was 2 or more, but actually if it was more than 2, it's not in our syllabus for IGCSE, but at least we know this law, R, if it was parallel, equal R1, R2 divided by R1 plus R2. This is if they were 2, but if they were more than 2, you cannot use this law. You could use another law, which is 1 over R parallel equal, this is R total, equal to 1 over R1 plus 1 over R2 plus 1 over R3. And remember, that law is not in IGCSE. خلاص؟ Types of connections يا ولاد. Then خلاص, we will start the paper. For a series, I could say here, V total equal V1 plus V2 plus V3 plus whatever, how many components that you have in the circuit. And it means, the current passing through any component should be the same. So the total current equal to I1 equal to I2 equal to I3. Remember, when we explained that, we said, if I have 3 components in the circuit, so the potential difference across the first component plus the potential difference across the second component plus the potential difference across the third one, if you add them, it gives you the total V. But the current in the entire components in the circuit should be the same because this is series. When it comes to parallel connections, so V across any one parallel with another one, it should be the same. Whatever how many parallel branches that you have, but the potential difference across any component equal to the potential difference across another component which is parallel with the previous one. If they were parallel, so the potential difference will be not shared. So that's why most of the electric appliances in our homes connecting parallel to get the benefit of the entire potential difference. But when it comes to the current will be less. So I'm going to say here the current, the main current, it could equal to the current in branch 1 plus the current in branch 2 plus the current in branch 3 if we have. Right? So the 2 connections or 2 types of connections, they are totally opposite. And we will see that through the paper that we're going to do right now. That was the laws about electricity. And I think we don't have any more laws in physics. Let's go, or let's get in this paper and start it from the beginning to the end. We will not take exactly the time. We could take more time because I'm going to explain the entire syllabus when we explain this paper right now. Any question before I switch to the another screen to solve with you paper 4? Any question, ya Sada? For the people, if you are in a software doesn't allow you to speak, you can write in the comments whatever you want. Right. Anyway, I'm gonna switch my screen right now so we can solve this paper together. Guys, if you want to hydrate yourself, drink some water, do something, please have it now. Please make sure that you have this paper in front of you. I mean, February, March 22, paper 4, variant 2. There is no variant 1. So there is no variant 1 in this session, February, March 2022. Make sure that you have this paper. One more minute to just join you. Can you see the board, يا سادة? Can you see the exam board? Yes. لا يا your mic is very annoying, so you can write in WhatsApp even. It could be much better because really I couldn't hear your voice. I'm just asking the rest of the people, can you see the exam in front of you on the screen? Just make sure that we are right.
Yes.
Okay, fine. Safe. If you have a question, please just announce it and send me in WhatsApp or send me in the chat room or whatever. But your mic is not that much good. I couldn't hear you fine. So right now you have two screens. One of them show the camera and the other show the exam paper. Please put your pen over the exam paper. I'm gonna do it together right now. I switch off my camera just to avoid confusing. Okay, fine. In this paper, we said that before in many videos, like the candidate name, you're going to write that. If it was not written for you, the center number, you will have it in the center number itself. They will announce it in a board, a big board. You write it and make sure that this word is written in the question paper, which is the extended. This is very important. This is your paper. And we read that before in many videos, like answer all questions. There is no choices. Use black or dark blue pen. And you could use pencil for drawing or for some other figure. And this paper is a little expensive because it's 80 marks. The total mark, it's 80. As you see here, you can see that it's 80 mark. And to be honest, this is the louder paper or the most expensive paper that we have. To know the system, 20% for paper 6 said that, and paper 4 could be 50%, and paper 2, we still have time for paper 2, it's just 30%. So this is very important. Please keep yourself totally focused for paper 4 when you solve it. As usual, don't use any correction fluid. Don't write in any barcode. It could delay your results. And you can use your calculator, but my advice, please use the calculator just if it was in need. Like for some little calculations, you can use your mental math if you trust yourself in this. It could save a lot of time, right? Now let's go through this question. Question 1. A ball rolls down a ramp and onto horizontal surface. The first section of the horizontal surface is smooth. So down a ramp, this is the first stage, then horizontal surface. The first section of the horizontal surface is smooth. The word smooth in physics means we can ignore the friction surface, we can ignore the friction coefficient or its friction force. There is no friction force. The second section of the horizontal surface is rough, so we cannot ignore it. Figure 1.1 shows speed time graph for the ball. So let's go through this. And I can see here in the first part of the graph, very positive straight line. It means there is an acceleration, constant acceleration. And I can also say that in the acceleration here is almost 10. This is the graph, the acceleration, or a little bit smaller. But anyway, state the time when the ball reach the start of the rough section. The start of the rough section here, it means, it could decelerate. So the speed in the beginning was increasing, then the speed is constant, then the speed start suddenly decrease because of the rough section. So actually this is the point that we need to announce. And they said here, state the time. So I'm gonna write the time is gonna go down, throw this. It's here, it's over here. So this is 2 and this is 2.5. What do you think? What's the reading of the time here? Yes, Ad. It's 2.2.
2.2.
Yes, each 2 divisions represent 0.1. So this is 2.2. I'm going to write 2.2 and the measuring unit is second. This 1 mark may be cancelled if you miss the measuring unit. And also it's written in the instructions. Explain how figure 1.1 shows that there is no resultant force on the ball when it rolls along the smooth section. Actually, if you go back, this is the idea of the smooth section. The speed was constant. So I'm going to write here how this figure, so I could write the speed from the figure, is constant. It means the acceleration is 0, and it means the total force acting is 0. And this is what they ask you to write. So from the graph, I can say that the speed is constant, the acceleration 0, and also I can say that the slope of the graph is 0. And if so, it means the total force acting is 0. Fine. Can I move?
Yes.
For C, using figure 1.1, determine the acceleration of the ball as it rolls down the ramp. So we need to find the acceleration here. As it rolls down, it means this is the first section of the graph. I mean this part of the graph. You need to find out the acceleration of this graph, this part here. I just highlighted. So, change in y divided by change in x. So change in y, I'm gonna take the entire graph. It's not required, but you have to. The reading here is, this is 12 point, so this is 11. So I'm gonna write here each 1 division 0.2. So this is 12.2, 4, 6, 8. So this is 12.8. The reading down here is 0. This is change in y. Divided by change in x. Again, for x here it's 0, and for y it is that number, which is 1.5. So change in y divided by change in x, I'm going to say 12.8. 12.8 minus 0 divided by 1.5 minus 0. 1.5 minus 0. Actually, this is, it could be represented by the slope, and the slope represent the acceleration. So it means 12.8 divided by 1.5. Could you calculate it for me?
8.53.
8.53. So my advice, I have 2 decimal places, and most probably here, and one decimal place and 2 sig fig. This is the minimum, so I could write here 8.5. The measuring unit, it's supposed to be, who can tell me the measuring unit here? What it's supposed to be?
Meter per second squared.
This part is in meter per second, and this part is in seconds. So meter per second, it means meter per second square, and this is normal acceleration. Okay, we're fine. The pole starts from rest at the top of the ramp. Show that the length of the ramp is 9.6. How could I find the length? It is the distance. So it's supposed to be the area under the graph. It's just for the ramp. So we need to find this area here. I just shadowed this area. So we need to find this area here, right? It looks like a triangle. This is for only the ramp. So the pole starts from rest at the top of the ramp, show that the length of the ramp is. So I'm going to write the length of the ramp is equal to, I could say that it's equal to the area under the graph. You know, for this idea, I got 1 mark. So have base times height, because the graph, it looks like a triangle. So the base here is 1.5 and the height is 12.8. So I'm going to write here have 1.5 times 12.8. Please do that for me.
Nine point
6. Okay, 9.6. It's supposed to be 9.6. Even if it was different, a little bit more or a little bit lower, so it's fine. It's about 9.6 meter. I'm gonna write here 9.6 meter. This is how to find it. It's equal to the area under the graph. That was the first question as well. I think it was very, very easy. Let's go to question 2. Figure 2.1 shows a spring balance used to measure the weight of a baby. The spring inside the balance extended when a mass is suspended from it. The DL shows the extension of spring as in value of mass in kilograms. Okay, so it's calibrated to measure kilograms. So the spring obeys Hooke's law up to the weight of 172 Newton. State Hooke's law. You know, the statement for Hooke's law is force equal to K times the extension. This is Hooke's law. You can write it in words even, like force equal Hooke's constant times the extension. You can write that way, or even you can use these symbols as a statement. State the relationship between the mass of the baby and the force exerted on the spring due to the baby. So I'm going to say here, the mass of the baby is directly proportional to that force. This is the relation between the mass of the force. By increasing the mass, the force will increase because the gravity acceleration is constant. That was easy. Then I, the reading on the spring balance is 8 kilograms. determine the force exerted on the spring due to the baby. So, you know, we have the mass here, and they ask you the force exerted by the spring. This looks like action and reaction. So that force could equal to the mass times gravity acceleration. So it gives you 8.0 times 10. It gives you just 80. I'm going to write here 80 Newton. That was easy. Even if you just do this determine without any steps, it's fine because it's just one mark. You don't have to show your work. The limit of proportionality of the spring is, guys, can I move? Have you finished?
Yes.
Okay. The spring obeys Hooke's law up to the weight of 175 Newton. So state, sorry. No.
Or you didn't swipe up.
No, it is fine. Is the screen frozen for any one of you guys?
خلاص it worked now.
No, it worked now.
Okay. So the limit of proportionality for the spring is at a force of 175 Newton. Sketch the extension load graph for the spring. The sketch must continue beyond a force of 175. Okay, fine. You know, you don't have to show the exact extension. I don't know it because there is no number. But I know, the relation is directly proportional up to 175. But beyond 175, I have two options. The first one is the spring may be, the graph line may be curved a little, like this one, or maybe curved a little like this one. So what do you think? Which one is right? The red one or the blue one?
The red one.
No. That's why I draw it in red. So the red one is wrong. Think about it. And no, after a certain value for the force, the extension will increase more than expected. The increasing for the extension should be towards the extension value. And the extension is in y-axis, so y-axis should increase more than x-axis. Right?
Mister, can you repeat?
Okay, I repeat it in two different ways. Like here we have two graphs. Just follow me in this. And sometimes when we ask you, we give you the force measured in Newton in y-axis and the extension in x-axis, measured in millimeter or centimeter or meter, whatever. Or extension measured in meter and forces measured in Newton in y-axis. I have two different graphs. The first one is, in both, the relation is directly proportional. Right? But keep in mind, when I reach to the limit of proportionality, the extension will increase more than expected. So I'm expecting in this case, the extension will increase more than the force. So the graph will be pinned a little towards the extension axis. Here is the same. The graph will pint a little towards the extension axis. Here is the difference between them. So once when I have more force, I have much more extension. So that's why the correct one is the blue one in the previous graph. This is comparable with this one. This is comparable with the down graph that I just drew. ماشي يا بني واضح؟
So Mr. if it was the opposite, يعني if the load was on the x-axis and the extension was on the y-axis, كنا نرسم the red one صح؟
If the load was in y-axis like this one here.
أيوة, and the extension was on x-axis.
Yes. This is what I mean. ماشي الحال؟ That was B. C. Really, the baby is carried from the ground floor to the bedroom. The vertical height of the bedroom above the ground floor is 3.5 meters. Calculate the change in gravitational potential energy of the baby when it's carried from the ground floor to the bedroom. You know, and now the potential energy, which is energy P, let me change the color, energy P, I mean the potential energy or the change in potential energy equal mgh. So the mass here, they give it to you like 8, I think. Was it 8? 8 kilograms.
Yes, 8 times 80 times 8
Yes,
times
8.0
3.5.
times 10. This is the gravity acceleration times the height, which is 3.5. Once when you calculate it, just write the measuring unit in joules. Because this is the 3.5 in meter, gravity acceleration in meter per second square, 8 is in kilograms, so the measuring unit could be in joules.
280 joules.
280 joules. Okay, fine. That was change in potential energy, and that was the question 2. Question 3. Kinetic molecular theory. The explanation is very important here. I have a way, like if you are facing any question and you need to explain something or describe something, use the blank pages in the exam to write the main ideas that you need to enhance in the answer, then copy it back again in the space provided to avoid lose your space, your limit space, because you don't have any other space except this one for this explanation. So write your explanation somewhere else, then copy it in a proper way. You could manage the number of lines and the number of words if you do so. It doesn't take that much time. Anyway, figure 3.1 and figure 3.2 show how a barrel of water changes on a warm, windy day. Barrel of water, we have a big amount of water to the left, low slide root surface. Then there in the other figure, we have a barrel of water 3 hours later, after 3 hours. And it's very clear the amount of water to the right is a little less. Describe the process by which the volume of water in the barrel decreases. Actually, it decreases by evaporation. So we need to describe the evaporation. خليني أسأل بقى سؤال هنا. Is it evaporation or vaporization?
Vaporization.
يعني أنا قلت الأول غلط.
Huh?
أنا قلتها evaporation. Is it evaporation or vaporization? Guys, what do you think?
Same thing.
No, they are totally different.
Vaporization.
Mister, your voice is not clear.
My voice is not clear. I didn't change anything.
Mr. It's clear, maybe she's lagging.
I tried to increase my volume, but anyway, I didn't change anything. Back to the question. Could you tell me, is it evaporation or vaporization, and why? They are different, by the way.
Vaporization. Because
لا بص يا سيف حبيبي، بلاش اللعبه دي معايا وانا بالله كمان. يعني انا ما اقولش evaporation or vaporization تروح انت قايل لي evaporization، ما فيش كده.
لا بس انا قلت والله vaporization بس مش عارف.
ما هي ما فيش evaporization اصلا، دي اختراعك انت دلوقتي حالا.
بس انا والله قلت vaporization.
ما evaporation or vaporization. Okay. The idea is keep that in mind. Sorry, I didn't get that.
Can I answer?
Yes, please.
It's evaporation because vaporization happens when a substance is boiling, I think.
Evaporation, happens at any temperature. That was great. But vaporization, that happens at boiling point only. خلاص ما حدش يغلط فيها تاني بقى. So the process that we have here is evaporation, because actually there is no sign for any boiling process taking place on the figure. It's just windy, hot day. There is no boiling, right? So I'm going to write here, this is evaporation. Evaporation. And let's describe this process, the meaning of evaporation itself. So I'm going to say, describe the process by which the volume of water get decreased. So I can say evaporation here. As we said, looks like a song. I can say, the molecules, the most energetic molecules at the surface get enough energy to escape. You can write here to escape and change into gas. That was very, very enough for the 2 marks. Right? So describe the process by which the volume of water and the barrel decreases. We just did. Then here B, state and explain one change in the weather that would cause the volume of water in the barrel to decrease more slowly. Remember, decrease more slowly. It's not decrease that much. Decrease, but more slowly comparing by what we have here. They said it's a hot or warm, windy day. So if we have no wind,
Less wind, no wind.
This one.
if we have no wind, or if we have lower temperature. So I will go to the lower temperature. So I'm gonna say the statement here at lower temperature. So the explanation here at lower temperature, so the energy gained by the molecules at the surface. Yes.
ينفع اقول له thermal energy gained
Thermal energy, eh?
gained by the molecules.
In which part? Statement?
Yeah, explanation.
Yeah, you can say that. Instead of energy, you want to substitute the heat energy or energy. Yes, it's the same. So the energy gained by, or the heat energy gained by the molecules at the surface could be less. And that means, low rate of evaporation. Fine. So if the temperature is low, so the amount of heat energy given to the molecules at the surface will be less. So the rate of evaporation will be low or will be less than before. Fine. Have you finished? Okay. Explain in terms of molecules how sweating helps to cool your body on hot day. Let's say that it's related to absorbing energy out of your body. So because cool here, it means take energy or taking energy out, right? So I'm gonna say here, the molecules, because we need to use these concepts, molecules. So the molecules, number one, the molecules of sweet take the energy out of the body number two, when the molecules evaporate, the rest of molecules have less temperature than absorbing or taking the energy from the skin, This is more than enough for the 3 marks. We almost explain most of the points. So the molecules of sweat take the energy out of the body. So that happens when the molecules evaporate. So the rest of molecules have less temperature, taking the energy to get them hot from the skin. That was for question C. Can I move to the next question?
Yes.
Okay, fine. For question 4, yes, almost 50% of the syllabus we just reached. A sample of sand has a volume of 0.05 meter cube. The density of the sand is 1,900 kilogram per meter cube. The specific heat capacity of the sand is, calculate the mass of the sample of sand. You know, you have the density and you have the volume. So here is the volume. I'm going to highlight it. And you have the density. You can use this to find the mass. Depending on this load density equal mass over volume, it means the mass, since mass equal density times volume. So the density that we know is 1900, it's given in the question, times the volume 0.050. Could you just do that for me?
95 kilograms.
95, and there is no more numbers. Is it not exactly 95?
Yes.
Kilograms. I'm going to write here, it's 95 kilograms. This is the mass of the sand. Now they said, calculate the thermal capacity of the sample of the sand. Remember, thermal capacity, when we explain in the beginning, it has a symbol which is Q, only Q. So we do not care about the amount of sand. At least the thermal capacity here means, since thermal capacity, which is Q, it is the amount of energy over the it's not a mass, over change in temperature.
Yes.
Change in temperature. But there is no change in temperature here. Let's find another law. Like, also we have the specific heat capacity here. I can use it. Like, Q, so it means, let's mention another law, just a minute. The other law is the specific heat capacity equal Q divided by M delta T. From that 2 laws, I can understand and know that Q or C equal to Q divided by M. You're fine. And they said thermal capacity. So from that law, Q equal Cm. Again, from that 2 laws, Q small, thermal capacity equal Q capital divided by delta T. Specific heat capacity that we have in the problem equal Q divided by M delta T. If you mix these 2 laws together, you will find that the specific heat capacity equal to this part, gonna removed, and instead of it, I will write Q small, still divided by M. If you use cross multiplication, you will reach to Q small equal Cm, right? Q small equal Cm. C here is the specific heat capacity, is just given, which is 1500, times the mass. the mass, we just find it, which is 95. So the answer will be
142,500.
142,500. Is it? Is it like that?
Yes.
Yes, Mr.
Okay, if it
Sir,
was
I
like that,
wrote it-
exactly. Huh?
I
Yes.
wrote it 1.4 multiply 10 to the power 4 kilojoules.
I write it like what you did. 1.4 times 10 power 1, 2, 3, 4, 5. Then this is the thermal capacity. It's not in joules. It's supposed to be joule per degree Celsius. So I'm gonna write here, it is joule per
Okay, sorry.
degree. Right? It is not
عادي لو
thermal energy.
كتبته it's fine if I write it in full form صح؟
Yes, yes, it's fine. Triple I, we still have something to calculate here. The initial temperature of the sample of sand is 7 degrees Celsius. The sample of the sand is heated using an electrical heater. The power of the heating element is 50 watt. Calculate the time taken to increase the temperature of the sand to 19. So we have it like here, it was 70, sorry, 7, and this is 19, and we have the power if you wish. So remember that, and we have this law, which is since Q equal mc delta t, we have everything except Q, the amount of energy, but we could find the energy by using power times time. This is the energy, still equal mc delta t. So we are fine. So depending on that, the time will be mc delta t divided by the power. The mass is 95. Specific heat capacity, it's 1500. Change in temperature, it was 7, now it is
12 I
19.
think.
Yes, 5 is that
12.
12, yeah, 12. So the change in temperature, it is 19 minus 7, again it be 12. This is change in temperature divided by the power. The power has been announced here 50.
50 watt.
50 watt. Yeah, so could you do this calculation for me?
34,200.
34,200. This is in seconds. And also it is a good idea to divide it by 60 and divide it by 3,600 to just find what's the time in minutes or what's the time in hours, or even you can keep it like this. But I prefer to change it into minutes. It will be much readable.
570 minutes.
570? Is it?
Divide by 60 صح؟
Yes?
Yes, 570 minutes.
70 minutes. Okay, fine. So we can keep it like 34,200 seconds or 550 minutes. نعم.
لا خلاص كنت بدي أسأل if we can keep it in seconds.
Yes, you can. You can. Now we have a little theoretical part, like in some countries, the soil is too cold for plants to grow well. In these countries, plants are grown in plastic pots, as you see here in the figure, and kept inside. The pots containing soil are placed on sand. The sand usually heated using an electrical heater, as shown in this figure. As you see here, we have a sand. Inside the sand, we have a heater. This heater will increase the temperature of the sand, and the plastic pot is immersed inside the sand to get some heat energy. So it could be suitable for the plants to grow well in some countries. But they said here, describe in terms of molecules how thermal energy is transferred from heated sand through the base of the plastic pot. Actually, they are all solids. So we're going to speak about the amount of energy, kinetic energy here. I mean, thermal energy is transferred. And there are also, we need to mention the word conduction, right? So I could write here from the heater. So the heat energy transfer from the heater to the sand. This is not required for the question, but this is just an introduction. Then they said transfer from the sand to or through the base of the plastic. I'm gonna then to the plastic by conduction. And we need to mention something related to kinetic energy. So I'm going to say here the kinetic energy, K, kinetic energy transfer from molecules to the next molecule by conduction. I have two main ideas I mentioned here. The transferring from the sand to plastic by conduction. So I got 1 mark for this for this similar idea, and the other one, the transferring of kinetic energy. That was the second part. The transferring of kinetic energy for the 2 marks. Okay. In II, the heating element in figure 4.1, which is immersed inside the sand, remains switched on. The temperature of the sand remains constant at a value above room temperature, a little bit higher than room temperature. And they said, explain why the temperature of the sand remains constant. Because the amount of energy in equal to the amount of energy out, or the amount of energy given by the heater equal to the amount of energy lost to the surrounding. So I'm going to write that down here. Due to the thermal balance. The meaning of thermal balance here means the amount of heat energy, the heat energy given by the heater is equal to the heat energy lost. That's why there is no increase or decrease in the temperature. In this case, what we called it thermal balance. This is what we called it, thermal balance. Okay. That was this question. Let's go to question 5. Now waves, the second part on the syllabus. They said here, boy looks at the image of a clock in a plan mirror. Figure 5.1 shows the mirror, the clock, and the position of one of the boy's eyes. Anyway, we have a mirror. This is the boy's eyes, the symbol, and we have a clock. And they said, on figure 5.1, draw a ray of light from the clock reflected to the boy's eye. I told you before when we explained the course, you don't have to do like a normal one instant ray, like this figure, one instant ray, then measure the angle, then reflect it back to the eye, or sometimes you can draw it in an opposite way from the eye to the mirror. then reflected back to the clock. No, actually, I don't like this way. Told you before. The idea is use your ruler to measure that distance to the mirror, and then repeat that distance again to the other side to find exactly where could be the image. I'll try to do it right now. So this is copy, and here I'm gonna do it, paste. It does not work. Anyway, so the idea is repeat the length on the other side. This is almost the same length. So this is the position of the image. Here. This is the first step, right? Make it easy for you. Then these two lines are useless for you. Just raise them. I just draw the image first. Then what you need to do is just extend the extension of the rays. I'm gonna do it right now here. And the reflected ray to the eye. That was the first part and the second part. Then you need to draw the incident ray. So the incident ray is just a straight line coming to that point. So here, this is the incident ray. This is the reflected ray. The upper one is the what we can say it's the extension, right? Without measuring any angles, it could be exactly the same. So they said here in I on figure 5.1, draw a ray of light from the clock reflects to the boy's eye. We did. This ray we just draw it. Double I on figure 5.1, mark with letter X the position for the image of the clock. We did. So this is X. State whether the image formed by the mirror is virtual or real. Any mirror, it should be virtual. And explain your answer. I'm gonna write here it is virtual. And we have many reasons for that. I could say the most common reason, the correct one, is formed by extension of rays, not real rays. Formed by extension of rays not real rays. Okay, perfect. مفهوم الكلمتين دول يا ولاد؟ Any problem in this figure? انت يا ابني واضح؟
Yes.
طيب and figure 5.2 shows the image of the clock seen by the boy. Let's see. The boy now looks directly at the clock. On figure 5.3, draw what the boy sees. You know, in any mirror, it could reverse the image. So the right becomes left, but the top still top and the bottom still bottom. So I'm gonna redraw the same figure. The top still top, so this arrow is still the same. So I'll try to draw it. But the other arrow, instead of to the right, it could be to the left. Any objection? Please let me know. It's erect and it's reversed. Erect, so the up still up and the down still down, but it's reversed. Like if I write here 6, it could be looks like this way. If I write here 12, could be looks like this way. This is what we call reversed, but it's not upside down. This is the figure. How could you draw it? Let's finish it. The clock is illuminated by a source of monochromatic green light. State the meaning of monochromatic. We said that many times. We have monochromatic, dichromatic, tetrachromatic, trichromatic, hexachromatic. Heptachromatic, decachromatic, all this, it means numbers. So mono here means one. Mono here means
A
one.
light with only one frequency.
A wave
Yes.
with only
So I
one
could write here, it is light.
مستر a wave يا مستر.
ما هو انا استخدمت نفس اللفظ اللي هنا يكون افضل. انا بحب دايما كده. You are right. You are right. It is a wave because light is a wave. بس يعني it's written here monochromatic green light. فانا ما حبيتش اغيرها لمونوكروماتيك wave. فاهمني؟ So I use the same concept. So it is a light characterized by or with one specific frequency and for sure one color. That's it. The green light has a wavelength of, calculate the frequency of this green light. So any frequency equal to velocity divided by the wavelength. You don't have the velocity, but you need to memorize it because you don't have a data booklet, right? If that was the speed in light, so it could be 3.0 times 10 power 8 divided by the wavelength. They give it to you like 5.6 times 10 power negative 7. Remember, the results will be a very, very big number. This is the frequency of the green light. يلا بينا حد يحسب لي ده. One point cam times 10 power cam.
نطلع لي 5.4 times 10 power 14.
4 multiply 10 to the power of 14.
Okay, fine. 5.4 times 10 power 14. And remember, the frequency measured by 1 over second
مستر
or hertz. قول يا ريس. نعم.
هو انا طلعت هو لازم نعمل change it to the nearest number يعني ولا ممكن اسيبها زي ما هي.
Can I have your number? Can I have your answer?
5.35 times 10 14
Times 10 power
14.
14. You can leave it like this, but let me tell you something. I have two numbers here. It's just two numbers. How many decimal places and how many sig fig? The priority for the decimal places. How many decimal places that we have in both? One. مش كده يا يوسف يا سيف. هي 1 يا بابا. One decimal place for both.
حضرتك تسألني؟
So I need to follow the same sequence in the numbers here. So I used one decimal, the priority for decimal as we said before. So it is 5.4. It will be much better comparing by 5.35. Right? If you want to keep it, it's okay. But regarding to the lows and regarding to the sequence of numbers on the accuracy, 5.4 is much better. The measuring unit here is hertz, or you can write 1 over second as a measuring unit. One announce here, the velocity is meter per second. The wavelength here is in meter, so this meter will cancel this meter. I still have 1 over second, or hertz. This is the measuring unit for the frequency. Okay, let's go. Can I move to the next question?
Yes.
Okay, fine. And the next question, yes, magnetism. We are almost done. Figure 6.1 shows 2-bar magnet NS. On figure 6.1, sketch the pattern and the direction of the magnetic field lines between the bar magnets. My idea is to draw this line and a similar line down Then in the middle, we have two other straight lines. It could be much better. The direction from N to S, as you know, so this is the pattern of the magnetic field lines between the bar magnets. As possible, keep the distance between two successive lines constant. Right? For A, خلاص, we have done for A. One mark for the distances. It should looks like equal by I. So let me modify this. It could be a little down here. Yes. And the direction from N to S, the direction of the line, this is for the second mark. B, figure 6.2 shows the same bar magnet with a coil of wire between them. As you see here, we have a galvanometer. There is no source of electricity, and there is a direction of rotation for handle. So this is a generator, it's not a motor. When it comes to generator, so I need to use my right hand if it was required. Let's see. Name the part labeled A in figure 6.2. مين فاكر؟ The part labeled A. البارتس دي اسمها ايه يا اولاد؟
Ring.
Yes, two rings, or you can write two slip rings. It's not split. They are not splitting yet. This is two rings or two slip rings. So they said here the coil of wire rotates in the direction shown in figure 6.2. The direction is when my eye is down, I'm going to see it rotate clockwise direction. In figure 6.2, draw an arrow to show the direction of the current in the coil. Explain your answer. My answer will be according to the right hand rule. But let's say it. If I use my right hand rule, so my finger will be directed. Remember, this is the right hand rule. Let me draw it here.
Sir, why is it a generator?
Sorry?
Why is it a generator?
Yeah, you know, motor, the motor itself, it needs electricity, right?
Yeah.
Can you see any source of electricity here?
No.
So the device is generator to produce electricity, not to consume electricity. This is what I mean. Fine?
Yes.
I just want to remind you by the right hand rule. The right hand rule here could be from this is my smaller finger and this is the longer one. Then I have the third one in this direction. Then I have two more fingers in my hand. Remember, in that finger, it tells you the direction of the magnetic field lines, mainly from N to S. And that finger here, the shorter one, it tells you the direction of the force acting or the direction of the motion, force or motion. And the longer finger, it tells you the direction of the induced current. The current. If you apply this rule on the figure that you have, I'm going to apply it right now from N to S. This is my middle finger. Then my finger. Then the smaller finger, it tells you the direction of motion, like here up. So you will find that the longer finger, it's directed into the page. So this is the direction of the current into the page in this branch. If you apply the rule in the other side, the motion is down. So this is the motion or the force. So make your smaller finger directed down, and the mid finger is directed from N to S. You will find that the longer finger, it tells you that the current is out of the page. So this is the direction of the current in this side, right? So we draw two arrows to show the direction of the current, but one arrow was more than enough. Is it clear, ya Sada, how to use the right hand rule? Did you apply it now in the figure? انتوا يا اولاد ما بتردوش ليه؟ واضحه ولا مش واضحه؟
Yes.
Okay, fine. So let's see. the coil of wire is rotated in the direction shown in figure. So on this figure, draw an arrow. Khalas, we did, to show the direction of the current in the coil. Explain your answer. So I'm going to write here simply by using the right hand rule, the direction of the current will be as shown. You know, I got 2 marks for this. The first mark is for the idea of the right hand rule. And the second mark for the idea of the arrow here, which is in that part. Right? So 1 mark for the rule and 1 mark for the arrow we just draw. Triple I, explain how rotating the coil in figure 6.2 continuously causes the generator needle to show an alternating current. We need to explain it in a proper way. Like if I continue to rotate that, it gives you a current in the galvanometer. Then by keep rotating it, it gives you a current in the opposite direction, then in the opposite direction, and so on. So the needle of the galvanometer will keep vibrating right and left, left and right, and so on. This is what we call alternating current. It kept vibrate right, left, right, left, right, left, right, left, and so on. So how can we explain that? Let's see. Number 1, by rotating the coil, the coil could cut the magnetic field lines. Number 2, the current induced in a certain direction. Fine. Then, number 3, after 180 degrees, what will happen to the direction of motion? If the coil is moving up, after 180 degrees, it will start moving down because of the rotation. Think about it. And the coil is rotating right now. So after 180 degrees exactly, by moving up, it will start move down. Between up and down, we have 180 degrees. Between right and left, we have the same. So after 180 degrees of rotation, I could say that the direction of the coil will change. And that will be producing a current in the opposite direction. Which is AC current. Right? So every 180 degrees, the direction of the current will be changed. It means it's alternating current. It's not a direct current because of changing in its direction.
Mister, can you repeat the second point again?
And the second point was said the current induced in a certain direction. Look at the figure here. So imagine that we are this branch, the red branch is moving up. This red branch is moving up, right? So once when it becomes at the maximum up, it will start moving down. Then when it's in the maximum down, it will start moving up. Moving up, it produces current. Moving down, it produces another current in the opposite direction. That's why we keep rotate, so we keep change the direction of the current produced. And this is what we call alternating current.
Okay, Mister, thank you.
Okay, fine. خلاص, that was for 4 marks. This is more than enough for 4 marks. Let's see question 7. Figure 7.1 shows a circuit including a 12-volt battery and 2 identical lamps. We can see them, identical lamps over there. The 12-volt battery consists of cells connected in series. You see, each cell in the battery has an EMF of 1.5 volt. Determine how many cells are in the battery. This is very easy. We said it's 12 and it's 1.5 volt each. So to find how many cells, it means 12 divided by 1. Yes, I'm gonna say here it is 12 divided by 1.5. It gives you 8 cells. That's
Mr. Can you go us up 1 second? Okay, خلاص, thank you. Mr. Thank you.
Okay. The second part for BI, when the switch is closed, the ammeter reading is 2.4 ampere. Calculate the total resistance of the circuit. Fine. We have the total potential difference and we have the total current, because the ammeter here, it reads the total current in the circuit, so we can find the total resistance. So I could write here the resistance total equal to V divided by I. I got 1 mark out of 2. V here was 12 divided by the current, which is 2.4. It gives you, do this calculation for me. For the people on YouTube, could you please enhance yourself in this, even if you have no mic, but at least you can write comments and I can see it. كم يا ابني? 5?
Yes.
Okay, so it is 5.0. So I'm gonna write here the resistance is 5.0 and the measuring unit is ohm. The measuring unit is ohm. Each lamp has a resistance of 3 ohms. Calculate. So let's see, each lamp has a resistance of, what did this say? 3. Oh yeah. So if we have a 3 ohms here and we have 3 ohms here, we need to find what's the resistance of Q. That's pretty easy. Like, let's find the total resistance in parallel first. Right? So I'm gonna say here, the resistance in Q equal to the total resistance minus the resistance parallel. The total resistance is 5 minus the resistance parallel. It could be 3 times 3 divided by 3 plus 3. If you have any doubts in this, please let me know. Do you have any doubt on this point?
No.
Mr. Can you
Can I what?
repeat?
Yeah, it's I'm gonna repeat it, but in a different way. Like, we know the total resistance of the circuit, we need to add this part, this resistance, with that one, because they are series. This one with this one, they are series, right? And they said here we have 3 and here we have 3. Let's fine, let's do it. Let's do it. So I'm gonna say for the parallel, the total resistance equal to the resistance parallel plus the resistance of Q. And I agree with that. This is so clear. I just add them. The resistance total, we just calculated, it is 5. Equal to the resistance parallel, because they are parallel, 3 and 3. So it's supposed to be 3 times 3 divided by 3 plus 3. Usually, it's supposed to be 1.5. The total is 1.5. So 3 times 3 divided by 3 plus 3. 5. Still plus the resistance of Q. So regarding to this, the resistance of Q is equal to, I'm going to transfer this part to the other side. So it could be 5. Yes, 5 minus 1.5. It gives you 3.5. So I'm going to write here 3.5 ohms. Is it clear?
Yes, thank
Yes.
you.
Okay, fine. But you don't have to show all the steps. It's just 2 marks, one law, one piece of the law, and the final answer and the measuring unit. It could be fine. Let's see. On figure 7.1, draw the symbol for a voltmeter that measures the potential difference across the two lamps. You know, across the 2 lamps, you can draw it below them. And you know the voltmeter should connect parallel. So I'm going to connect it parallel this way. So this is a voltmeter. Okay, perfect.
مستر هو كان it has to be parallel. ما ينفعش تبقى from next to this يعني from here from the right side to the left side ما بين يعني وهم يبقوا between them.
Like before Q and before the vertical line.
أولا هي the first part of your question, is it has to be parallel? Yes, it has to be parallel. But all this figure will be parallel. Like, let me use many colors. Like this one, still parallel.
Okay.
أيوة I mean this one. This one's okay.
أيوة يا ابني.
Okay.
Again, this one still parallel. بس هي ما فيش داعي لخبطة الأسلاك دي. خلاص. So I think the blue one is the most cute one.
لا يا مستر the red one.
لا هي دي. ماشي الحال؟ Okay, so this is how could we connect it. Okay, fine. We did draw this, and they said calculate the on figure, draw a symbol for voltmeter. خلاص, we did. Calculate the power supplied to 1 lamp. You know, we can find the power by many laws. Like, we need to find the power here. I know the resistance and I know the current in each electric bulb. It depends on the reading. So we can say that since any power equal to V times I, but actually here we have a problem. We need to find V. It doesn't take that much time, but we can find it. But instead, because I have the current and I have the resistance, so instead of that, what do you think if we substitute V by IR? So in this case, the power will be changed to be I square R. Now we are fine. Now we are fine. So I'm going to use this law, the power equal, what's the current in the circuit? The whole current is, what they said about the current here, 2.4. So I'm going to write 2.4. This is the current. So 2.4 square times the resistance. The resistance of both is 1.5. So I'm going to write here 1.5. It gives you the power consumed in both, then divided that by 2. Right? So now I'm going to use this law into the power equal I square R. So it gives you the power in both these 2 electric bulbs which connect parallel. Then you can use that power divided by 2 to find the power in just 1 lamp, because they mention here 1 lamp. Could you help me in this? 2.4 square times 1.5. What's the answer?
8.64.
8.04.
64.
64. 8.64. Okay.
8.6
so
watts.
Isaiah.
لا ولا حاجة.
Okay, so this is the power in total. So the power for 1 electric bulb, it could be 8.64 divided by 2. It's going to give you the power for 1 lamp, which is 4.32 watt. Right? This is a way. You can use another way if you think about the potential difference. Like, we can find the potential difference here. This potential difference equal to the, let's do that here in that side. The potential difference equal to IR. The current passing here is, the current, they said 2.4 times the resistance is 1.5. Could you do that for me? .6, I think.
Yes.
3.6, yes.
3.6 volts. So we can do that again in the power equal V dot I. The potential difference is 3.6 times the current passing here is 2.4. So I think it's suppose the current is 2.4. Yes. So what's the current? Could you do that for me, please?
Same answer, 8.64.
8.64. This is for the 2 lamps. It means for 1 lamp, it should be 8.64 divided by 2. It gives you 4.32 watt. So it's the same answer. Whatever the law that you are using, it's gonna give you the same law. Remember, power equal VI, power equal I square R, power equal V square divided by R. Any law of these could work, and it could give you the same answer, right? Use any one of them which you feel easier. Let's go to 8. A radio is connected to the main supply using a step-down transformer. Draw a label diagram for the structure for the basic step-down transformer. Let's make it fast. It's nothing. But remember, they said here step-down transformer. Step-down transformer. So step-down here, it means should be shown clearly. The number of turns in the secondary coil should be less. Remember, it should be labeled. So this is this coil. We're going to see right here V in, V input. And in the other side, the number of turns should be much less. And it's so clear from the figure, it's much less. So V out. Right? Explain the operation for the basic transformer, how it works. We have 3 steps. Number 1, the current, which is the AC in the primary coil, produces a variable, this is very important, variable magnetic field. Fine. Number 2, that field, the variable field, transfer to the secondary coil through the iron core. We forgot to write the labels here. This is iron core. Iron core. And here we have primary coil, and this is secondary coil. So that field transfer to this secondary coil through the iron core. Number 3, the variable fields get cut by the secondary coil, producing current. Producing current. That's it. So we have 3 steps for the 3 marks. Magnetic produced in the primary, magnetic transfer through the iron core, magnetic get cut again by the secondary coil to produce the output. This is the idea that you need to write. Okay. There is a little piece of calculation here. The voltage of the main supply is 230 volt. The output voltage of the transformer is 6 volts. Calculate the value for the turns ratio, NS divided by NB. Give your answer to 2 significant figures. It's written here clearly, which is easy for me, 2 significant figures only. So let's do that. We know from our studies, NS divided by NP equal to VS divided by VN, VP. right? Because when we have a big primary volt, we have a big number of turns. So that's why VB NS equal VS NP. This law should be memorized well. So the ratio will be, potential difference is for the secondary coil, it's going to be 6 divided by 230. The number should be less than 1 because this is step down transformer. So when I say the number of turns in the secondary coil should be smaller than the number of turns in the primary coil. كم يا بني؟
0.026.
0.026. I still have two significant figures if it was kept 0.026. So you can write it like equal to, you can keep it like that, or you can change it to be 2.6 times 10 power negative 2. It's the same, but I prefer to keep it like 0.026. Let's see, here is the problem. To get the full mark, what should be the measuring unit here? You need to realize it. What's the measuring unit?
Nothing. No unit.
Smash.
No unit.
No unit, because this is just a ratio, so there is no measuring unit, right? So keep it like it. Okay, let's jump to the next question. Logic gates, we're about to finish. Figure 9.1 shows a digital circuit. Explain what's meant by digital. You know the idea of digital here. This is the digital circuit. So I'm gonna write here what difference between digital and analog. It is a circuit. It is a circuit using electric signal, not potential one. So we are using electricity instead of using the change in potential energy. This is what's meant by digital. For example, if we have a balance, we are using electric signal to show the mass in a state of potential energy stored in the spring of the balance, of the normal balance, which is the analog one. Anyway, that was the meaning of digital. They said here, table 9.1 is truth table for digital circuit shown in figure 9.1. Let's do that. Complete the column C, D. Guys, what's the name of this gate? The first one?
And
A and D. The other one?
diode.
Not
No, it's
As the
not.
sorry, and not yes.
It is not. It is not gate. Diode is different. Diode, it's like this.
معلش sorry.
So I'm gonna go down here. Now let's try them with different color. Like if I have 0, 0 here, 0, 0. So the output at C, it could be 0.
0.
The output here was, yes, so I'm gonna write here 0, 1. Right? Let's do it in another way. Like if you have 0, 1,
0.
it could be 0 here and 1
Then
here.
1.
So 0, 1. If we have 1, 0, I think it doesn't
0,
make any
1.
difference. Still 0, 1. But if we have 1, 1,
1, 0.
yes. So the product in AND, it could be 1. Then we have 0 here. So it could be 1, 1. So the product is 1. So when it passes in NOT, it's going to give you 0. State the signal logic gate that would produce the same output D from inputs A and B. It's so clear. One signal. One single logic gate. One single logic gate, it could give the product. It's AND and NOT, which is NAND. Thank you. So I'm going to write here NAND, N-A-N-D. So this is NOT and AND together. It's so clear. That was question 9. Question 10. In question 10, they said here, the isotope americium 241 is represented by this symbol, AM95 241. And they said this isotope decays by an alpha emission to an isotope of neptunium. Complete the nuclide equation for this decay. Let's see. You know, alpha, it's helium without electrons. So here we're supposed to have 2, and here we have 4. It's fine. We are fine. Depending on that, the number here will be -2, so we have 93. And the number here will be -4, so we have 237. Any objection?
Mr. I have a question.
Which is?
What if it was beta, not alpha?
If it was beta, let me write that down here in a different color because it's okay. If it was beta, if it was beta, so I'm gonna say AM. This is 95, and here 241. So I'm gonna produce beta. Remember, in beta here it is -1, and the mass number is 0, because the mass of beta could be ignored. And the material, I don't know what's the material, but let's give it a symbol which is X. It's already written. And this number will be increased by 1, so it could be changed to 96. And the mass number is still the same, 241. So here we have 96 plus 1, and this one still the same. If it was beta. ماشي يا سيدي؟ Okay. But I like your mic right now. It's working fine. Figure 10.1 shows a symbol diagram for a smoke detector. This is for fire, in case of fire, so it could give us an alarm. The smoke detector contains a small sample of americium 241. This isotope ionizes the air between the metal plates and the detector. Describe how the americium ionizes air. So let's write that. You know, it produces alpha. So I'm gonna write number 1 here by producing the high ionizing alpha. So number 2, the alpha get the electrons from air. Number 3, air without electrons, so air becomes ionized. So the air could be ionized or will be ionized. This is how the ionization could happen. And I think the 3 steps enough to get the 3 marks. Question double I here, in double I, suggest and explain 2 reasons why smoke detector uses an isotope that emits alpha particles rather than an isotope that emits gamma radiation. You know, mainly alpha is more safe because gamma, you cannot stop it, but alpha will be stopped by itself. Will stop by itself after 5 centimeters, and it will stay in the range. So I'm gonna write here, because the first reason is because it is very high ionizing matter, and it has very small range. you know, very small range, so it could stay inside the metal plate. It could be stay inside it. So it could be stay inside this range. It won't go outside. So it has very small range, which is around 5.0 centimeter. I think this is the two reasons why we could use this alpha in this devices. Any question, يا سادة?
Mr.
Yes.
I have a question, out of the paper.
Which is?
There is a class tomorrow.
Up to this moment, no, because I don't like to make it exactly in this same night. For paper 6, it was easy, but paper 4, please work as much as you can. And if you have a question, you can just like send me through WhatsApp or through whatever, any social media.
Okay,
And just send me the image. I can solve it.
thank
Right,
you, sir.
guys, I have finished, but before I leave, if you need any question, you know how to contact me. Could you please ask me right now if you have a question?
Yes,
Or
sir, I do.
yes, but before your question, I just want to ask Ali Ahmed. Ali, do you have any question? Because you sent like number 5.
Yeah.
لا خلاص ما فيش. طيب
Mr. I have one question بس.
خليني اشوف من مين اللي سأل الاول.
Okay.
اتفضلي يا فندم. اتفضلي يا فندم.
أول حاجة لما نيجي نعمل calculating بالتورج لازم يعني في سؤال بيسأل على التورج ده بيسأل على التورج وتايم. لما أجي أجيب التايم لازم لو هو مديني بالمينت لازم أحوله لأورز.
لا بس انت بتقولي لو هو مديك التايم بالاورز لازم احوله لايه؟ لمينتس؟
لازم دايما أحوله لمينت لأن لما كنت عشان في أحيانا السؤال اللي أنا كنت حلاه كان طالب إن أنا مش كاتب في السؤال بس لما عملت تشيك في الماركينج سكيم كان طالب إن أنا أحوله للمينت.
Listen. There is no minutes. The idea is if you want to use this time in an equation, it should be in seconds, right? And if you want to use the time in an equation, physics equation or scientific equation, it should be in seconds. But if they ask you about time, like this question that we have here, there is a question about time here to do some calculations for time, and we got the answer in seconds mainly. If you want to change it into minutes, yes, it's up to you, right? If you don't want to change it into minutes, it's still up, like this question. We got the questions in seconds, the answer in seconds. If you want to change it into minutes, it's fine. But if you will use this equation or you will use this time in an equation, the time it's supposed to be in seconds, not minutes.
But if it's in minutes, do I change it to seconds or hours?
Yes, you need to change it into seconds. It's much better.
Okay.
Not better. It could be cause a mistake. You need to change it into seconds. Yani, for example, if I said I have an equation contains time and gravity acceleration in the same time. Let me find it in this blank page. If I have the gravity acceleration, it has been given like 10.0 meter per second square, right? And the time has been given in 6.0 minutes.
Yeah.
You cannot add them in the same equation. Simply, أنا ممكن أقول كده 3 pieces of apple plus 3 pieces of grapes or dates, it does not equal 6 because they are not from the same type. هنا نفس الموضوع minutes, it's not like the same type of seconds. Here we have seconds and this is minutes, so they cannot add it or be in the same law. ما ينفعش. لازم واحد فيهم الاثنين. So minutes should be changed into seconds or seconds should be changed into minutes. فاحنا دايما بنقول work with seconds. So change it into seconds.
عندي كمان سؤال. في
اتفضل.
الميديم الميديم أعلى الأقل بيترسم إزاي؟ أو ميديم أقل الأعلى، إنه بتلخبط لما يجي يسأل عن إن إحنا نرسم ميديم.
بس انا لا ما سمعتش الصوت، في هواء عالي قوي في الميكروفون، فانا مش سامع
لما
كويس.
نيجي نرسم ميديمز من ديب للشادو أو شادو لديب، بتلخبط أي صح للشيب ديب شادو. لو
You,
يمكن حضرتك توريني إزاي بنرسمه
you
الميديم.
mean from shallow to deep? This is
أيوة.
what you mean?
Yeah.
Okay. Listen. Just to finish it, the idea is if we have shallow water or deep water and we have a wave coming over, so let me draw this. Imagine this is the surface of the water, and we have this ground for the water. So here we have a deep depth or long depth, and here we have a smaller depth. Now I'll send the wave. If we have a wave, I'll draw the wave in red, like this is the wave here. In this point, the wave will get into the shallow area, so it becomes like this way. Compare between the wavelength here and the wavelength here. Keep that in mind. The speed equal frequency times wavelength. The frequency cannot be changed. This is constant. So once when I have low wavelength, I have low velocity. If I have high wavelength, I have high velocity. So here this is high velocity, and this is low velocity. بتهيألي بقى when it comes to refraction, when I transfer from high velocity medium to low velocity medium, it could refract closer to the normal. If the opposite, it could be away from the normal. يلا نرسم بقى. But I will put my eye over this figure here to see this figure. Like here, this is the pattern. This is the deep water, and this is the shallow water, right? And now I have some waves coming on. Like I have this wave, and this wave, and this. It's the same wave, but I need to draw many patterns here. Okay, so the direction of this wave is now it's transferring from deep water to shallow water, right? Depending on what we drew before, the speed will decrease. So it could refract closer to the normal. So the wavelength becomes less. I will draw two options, one of them right and the other is wrong. So this is the shallow water. And you tell me which one is right and which one is wrong. So this wave becomes this one and this one. This is a refraction. Maybe happen. I draw the first one. The second one is it may be refract to be here, and this one to be here, and this one to be here, and maybe okay, this is enough. So the blue wave, it could move in this direction. The red wave, it could move in this direction. And this is the original one. Here, this is the original one. Yeah, what do you think? Which one is correct? The blue one or is the red one?
The red one?
No, the blue one, because we said here, the wavelength becomes smaller.
Okay.
Look at that. The wavelength becomes smaller. Is the wavelength smaller in red or blue? In blue. So the wavelength here is very small. It becomes less. But the wavelength in red, it's very big. And the wavelength here is the original one. So the wavelength reduced in blue one. So the blue one is correct. This one is wrong. When it comes from deep to shallow. But if the opposite, the wavelength should increase. واضح؟
أيوة شكرا. عني عايش برضك سؤال كمان هبعته على الجروب.
اوكي
سؤال
نو بروبلم. علي باشا كنت عايز تقول حاجه؟
مثلا بس بتلخبط شوية في الرايت هاند رول دي مش فاهمها شوية.
ما احنا ما قلناها من دقايق. اللي خليني امسح بس ده الاول. anyway it's recorded so you can go back to it. الرولز اللي عندنا للايد هي الاتي. احفظ يعني اكتب الجدول ده معايا يا حبيبي. يقول لك ايه؟ if we have a current, imagine انه this is a page and we have a wire passing through this page. So it's the same wire and the current is moving up. So the magnetic field lines will appear like this. Depending on this direction is the direction of the magnetic field lines, right? This direction. How could I know the direction? Think about it. It's the right-hand rule. This is my right-hand rule, and here we have 4 fingers. This finger, it tells you the direction of the current as shown. And these 4 fingers, it tells you the direction of the magnetic field lines. تالي في صباع ناقص هنا. ماشي. خلاص؟ That was the first rule. The second rule, if we have a solenoid, like this solenoid, okay, this solenoid, and I have a wire passing through, current passing through this wire. So the direction of the current, depending on that, is in this direction. This arrow to show you the direction of the current. How to know the magnetic field lines? I'm going to use the same right hand, 4 fingers. يا طبعا الايد مش هتطلع مظبوطه يعني شكلها مضحك بس يعني مش مشكله يعني. خليني ارسمها كده. So hands. Okay. So this is the direction of the current. Sorry, this is the direction of the current in the fingers here. Current, 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 current. And this is the direction of the magnetic field lines. واضح يا بني؟ ادي حالتين.
اوكي مستر.
تعالى بقى في ال right hand rule وال left hand rule. So this is the right hand rule. حاسم ايدي اليمين. So it gives you this direction. Then I have 2 more fingers. Then I close it. So here, this is the direction of the force اللي احنا بنسميها motion. If the wire move up. And this is the direction of the magnetic field lines. And this is the direction of the. امتى بستخدم ال right hand rule? In generator. وخلي بالك ان اللي فاتوا دول كمان right hand وهنا right hand. كل ده right hand. خلاص؟ طب ال left hand rule, I'm gonna use the left hand rule in motor. Left hand rule هتبقى بالشكل ده. It's the same, but I'm gonna use my left hand. Right? So this is the direction of the force or the motion. And this is the direction of the magnetic field lines. And this is the direction of the current. And this is usually left hand rule. This is usually used in motor. وكمان لو تفتكر في اخر chapter في radioactivity and alpha, the deflection of alpha due to magnetic field. So I'm gonna use my left hand rule. بس هي دي كل الرولز بتاعت الايد اليمين والايد الشمال اللي عندنا، ما عندناش غيرهم والله. ماشي يا باشمهندس؟
Mr. Thank you.
Okay. Most welcome. Any other question؟ بس
بس
انت
أنا عندك question
بعتي حاجه على الواتساب صح؟ ثواني انا مش شايف.
Mr. I will leave, okay?
Okay, thank you. Good luck. If
Thank
you
you.
have a question. خليني اشوف what was that? The isotope of radon has a half-life of. Let me show this question. You here, guys? I have finished. I'm just solving some questions or some doubts. If you want to leave, it's up to you. But I prefer to stay. خلوني أوريكم الكويشن ده على السكرين so we can solve it together. أنا عايز أعرف يعني أنت ما كانش ممكن تبعتي الصورة وهي البوزيشن المظبوط بدل ما أنا أقعد ألف. أوكي. Okay, fine. Okay, guys, can you see this?
Yes.
So this is the question that you just sent. هو بيقول لي هنا أنا بخاف عليكم من الأسئلة اللي من النوعية دي الحقيقة لأنه بيبقى فيها هنا background. I'm not sure if we have a background here or not. بس خلينا نشوف. They said here an isotope of radon has a half-life of 3.8 days. It decays by emitting alpha radiation. Calculate the time taken for 6 grams of this isotope to decay to 2 grams for this isotope. Yeah, that's this is easier than what I expected. That's why we have just 2 more. ركزي معايا يا بنتي. هو بيقول هنا it's 16 milligram. It could be changed to 2 milligram. What's the time needed for that? Let's do that. So I'm gonna say 16 divided by 2 power n equal to 2 milligrams. هنعرف نحل الايكويشن دي اهلا وسهلا. مش هنعرف try and error. هعملها ازاي؟ هقول كده 16 divided by 2 equal to 8. That was the first try. Then 8 divided by 2, it gives you 4. That was the second try. Then 4 divided by 2, it gives you 2. Now we reach from 16 to 2. How many divided by 2 that I passed through? How many half-lives? So the number of half-lives, the number, yes, of half-lives is 3 half-lives. The 1 half-life is 3.8 days. يبقى time عبارة عن 3.8 days times 3. تشوفي لي دي على الكالكوليتر وهي مكتوبة زي ما هي. يبقى 3.8 times 3 هيديني كام؟ 11.4 days وخلاص. بس هو ده الإجابة.
وفي سؤال كمان معايا.
اتفضلي يا فندم.
أنا بعته.
اوكي. بعتيه؟
بقى.
Mr. Can you repeat?
جبت ايه؟
This part اللي هو كل الكويشن سي.
ماشي. انا الحكايه كلها بلاش حكايه باور 2 دي عشان بتلخبط. خليني اعيد تاني. نمسح ده مره ثانيه. هعيد لك في السريع كده مش هتاخد وقت. بيقول لي ايه؟ it's written here we change from 16 milligram to 2. هقول كده so 16 divided by 2 هيديني 8. لسه ما وصلتش ل 2. try again. So 8 divided by 2 equal to 4. I didn't reach to 2 yet. So again 4 divided by 2 equal to 2. خلاص. Now we are fine. How many times that we divided by 2? 3 times. يبقى اقول له كده انه the number of half-lives is equal to 3. هو قايل هنا انه ال 1 half-life ب 3.8 days. فهروح قايل كده it means انه the time عبارة عن 3 half-lives. كل half-life equal 3.8 days. فده على كلامكم هيديني 11.4. So I'm gonna write 11.4 days. That's it. ماشي يا باشمهندس؟ فين السؤال؟ انا احط ايدي على السؤال. السؤال اللي انت بعتيه محلول اصلا يا بسنت.
لا دي
خليني اشوفه لكم هنا كده، انا مش شايفه على الموبايل. just 1 minute. اوكي. بتقولي بي هنا calculate the total distance traveled by the ship between time 42 minutes لحد 100 minutes. ما تروحي ال 42 هنا. فين 42 ده؟ 42 اللي انت عاملاه هنا مظبوط. طيب عايزين التايم، سوري الديستانس قالوا صح؟ ايوه الديستانس. الاريا اندر ذا جراف يا سيدتي، الاريا اندر ذا جراف. فاحنا ممكن نعمل ديفايدد للقصه دي. هقول كده this is area 1 this is area 2 this is area 3 اللي هي دي كلها. تعرفي تجيبي الاريا دي ولا ما تعرفيش؟ طيب عندنا area 1 عباره عن triangle have base times height. area 2 عباره عن rectangle. area 3 عباره عن rectangle. يلا نعملهم مع بعض. فهيديني كده the area under the graph for area 1. أقول هنا إنه it's the area under the graph equal to have البيز اللي عندنا التراينجل ده عبارة عن from 42 لحد 60. يبقى عندي تقريبا هنا 18 times الهايت. الهايت من أول دي 7.5 7.5 لحد 15. يبقى عندنا 7.5 تاني. دي الاريا الاولانيه بلس the other area اللي هي area 2 عباره عن 18 برضو times الهايت. الهايت عندنا 7.2 بس من 0 ل 7.2 خلاص 7.2 plus the third area from 60 to 100 عباره عن 40 times الهايت اللي عندنا 15. بس يا بنتي اللي يطلع هيبقى بالمتر خلاص. بس هو طبعا في مشكله هنا. في مشكله هنا. الامتحان ده منين؟ جايب الامتحان ده منين؟
ده في الريفيجن شيت.
ماشي. عموما على اي الحالات انتوا في مشكله هنا صغيره انه هنا in minutes ودي in second. خلاص. ف you need yes you need to change every single time اللي تحت اللي هي الارقام اللي تحت دي into seconds. هنعمل ايه؟ times 60. يعني هناخد الرقم ده اي رقم اتكتب تحت اللي هو مثلا زي 18 دي هنقول times 60 عشان تبقى in minutes. لانه ال 18 سوري in seconds لان ال 7.5 دي بالمتر بير سكندز مش بالمينت. وبرده ال 18 دي هتبقى times 60 وانتوا بتكتبهم. واخر حاجه عندنا هنا ال 15 هتبقى هنا برضو تايمز مش ال 15 لا ال 40 اسف هتبقى هنا دي الاريا الاولانيه. الاريا الثانيه الاريا الثالثه اللي هي 40 من اول 60 ل 80 so it could be times 60. يعني كل حاجه خدتها من التايم ان مينتس اللي هو على الاكس اكسس هضربها تايمز 60. واضح؟ بس والناتج اللي هيطلع خلاص هيبقى هو ده.
شكرا سيف.
عفوا يا فندم. سيف انت باعت ايه هنا؟
مستر ممكن بس تجاوب الكويشن اللي بعته لحضرتك؟
عينيا حاضر. بس خليني اشوف الكويشن ده عن ايه. بيقول لي هنا each group of solar cell. خليني اشيره معاكم لان انا مش شايف من على الموبايل. شير. فاين. هو بيقول هنا each group of solar cell is arranged in a rectangular 1.2 meter times 2.8 meter. The solar cell are situated in a region where 260 watt of solar energy is received per square meter of the cell. The electrical output of each group of solar cell is a current of with a potential difference of. Okay, fine. Calculate the efficiency of the solar cell. خليني بس اشوف حاجه هنا. هو مدي هنا each group of solar cell is arranged by a rectangular. The solar cell are situated in a region where solar energy is received per square meter. So here I can find the area. خليني اكتب دي هنا edits. بص يا باشمهندسين، هو بيقول هنا I can find the total area in meter square، وهنا this is for each meter square. اهو كاتب هنا for each solar energy اهو in a region where كذا solar energy is received by square meter per square meter. Okay, so I can find the total area, then I can find the total power in, then the total power out. خلينا نشوف الكلام ده. اقول هنا انه the total power received, the total power in اللي هو الانبوت equal to، احنا عندنا بيوصل لل 1 متر سكوير من from the sun 260 watt times الاريا اللي عندنا. الاريا هجيبها ازاي يا باشمهندسين؟ هقول 1.2 times 2.8. حد يحسب لي ده يا ساده؟ حد يحسب لي ده؟
$873.6.
لا ما سمعتش.
873.6.
3.6. Is it like that?
Yes.
Okay, fine. And the measuring unit هنا هنكتب ايه يا باشمهندسين؟ Watt. It is watt. ده في التوتال اريا. خلاص؟ تعال بقى نحسب the total power produced. ده الانبوت وده الاوت. التوتال باور اللي انا هاخده بقى بقول له هنا انه the total power out اللي انا استفدته فعلا out equal to. هو بيقول the potential difference for meter square of the cell. The electric output of each group of solar cell is الكرنت ده with potential كذا. طبعا كل جروب يعني each group of solar cell arranged in كذا، يعني دي الجروب الواحده اللي احنا لسه حاسبينها كده. فالاوت اللي عندنا هيبقى V times I اهو V times I، الجروب اللي هي لها المساحه دي اللي احنا حاسبين الانبوت بتاعها. الفي اللي عندنا يا باشمهندسين عباره عن 86 تايمز الكرنت عباره عن 2.5. حد يحسب لي ده؟
215.
215. fine. كل measuring unit هنا ستيل وات. حلو قوي. تعال بقى نشوف الافشنسي. خلاص ده last step. So the efficiency equal 215 زي ما انت قلتي. 215 divided by 873.6 times 100. الرقم اللي هيطلع هكتبه هنا وهيبقى ده الافشنسي. قريت السؤال؟ 34. اوكي فاين.
34.6.
ماشي وات ايفر، يعني هو المفروض 34.6 هكتبها بالشكل ده لو انا سمعت صح يعني. بس whatever the case is, when you read a question, make sure that you read it in a proper way. Like هو بيقول لي هنا each group of solar cell is arranged in a rectangular this area. وسأل تحت إنه each group produce this power اللي هو this V and this I. فأنا أبقى عارف أنهي area اللي بتكلم عليه. وبعدين هو بيقول هنا إنه 260 watt of solar energy is received by square meter. مش لكل الاريا، للسكوير متر بس. عشان كده رحت واخد الرقم ده اللي هو كده وضربته في توتال اريا عشان يديني التوتال باور receiving from the sun. وبعد كده هو مديني التوتال باور produced by the unit، اليونت اللي هي نفس الاريا اللي حسبت عليه. فبقى عندي باور ان وباور اوت. الريشيو اللي بينهم this is the efficiency. خلاص؟ فهاخد الرقمين دول divided by each other times 100 is gonna give you the efficiency. في حاجة تاني؟ مفهوم السؤال ده؟
Yes.
اوكي طيب في حد بعت حاجه تاني؟ مفيش حد بعت حاجه تاني. طيب anyway احنا مع بعض لحد بكره. I'm gonna share this class in the group. اللي عايز يذاكره تاني او يسمعه تاني، هو طويل شويه وممل، بس انت ممكن تسمع الاجزاء اللي تخصك يعني. لو في جزء سهل you can skip the video and see whatever you want. انا كده خلصت. يعني بعد الامتحان زي ما عملته كده المره اللي فاتت تبعتوا لي ايه الاخبار على الجروب عشان اشوف عملنا ايه في بيبر 4. بيبر 4 اهتموا بيها كويس يا اولاد وذاكروا كويس قوي وما تتعبش نفسك. مفيش حد يشرب بيبسي، ما حدش ياكل شيبسي يوم الامتحان. كلوا اكل كويس وناموا بدري. بلاش شيبسي وبيبسي ايام الامتحانات الله يستركم. بلاش اكل هبل، بلاش الاكل اللي هو الكيكات والاكل اللي بتشتروه اللي هو الفشار والكلام البايظ اللي بتشتروه من بره ده. انا بقول الكلام ده حتى لاولادي، انا بمنع الكلام ده خالص في البيت ايام الامتحانات الكلام ده. سيف انت بعت حاجه؟ ماشي يا ولاد، اللي عايز يمشي يتفضل. فين ده يا ابني؟ كويشن 11 مش كده؟
بعد اذنك.
طيب خليني اعمل شير لكويشن 11 ونشوفه تاني مع بعض. اوكي. بنعمل ازاي؟ تمام. شايفين السؤال يا اولاد اللي لسه موجودين؟ شايفين السؤال؟
اجيب لحضرتك صوره اوضح، اخلي الصوره اوضح شويه.
لا انا قادر اقرا، ما دام هي كبيره على الشاشه قدامي قادر اقراها، مش مشكله خالص، مش مقلوبه بس. هو بيقول لي هنا radon 222 nucleus contains 86 proton and 136 neutron. It decays by emitting an alpha particle and becomes a nucleus of an isotope of plutonium. The symbol for radon is Rn and the symbol for plutonium is Po. Write down the nuclide equation for this decay. طيب يا راجل، ده مش سؤال يعني. اهو هو مديك ال Rn فكاتب ال N وكاتب لك الارقام. قال لك هنا contains protons اللي هو 86 و نيوترونز. النيوترونز دول اللي هو 136. هتروح انت للنيوترونز دول يا ريس عشان تجيب الماس نمبر وتكتبه فوق. هتروح قايل انه 136 بلس النمبر اوف بروتونز اللي هو 86، فده هيديني 222 فوق. هو بيقول ده اتحوله كده الرادون ده changed to be in the بلونيوم، مش كده؟ هنقول البلونيوم. وقال انه emitting an alpha particle، الفا بس. طيب هنكتب الارقام تحت. هتشيل من دي زي ما اتفقنا من شويه، هتشيل من دي 2 فهتبقى هنا 84، وهتشيل من دي 4 هتبقى او 4 هتبقى 218. بس خلصت. ده الجزء اللي فوق واضح؟
واضح مس.
طيب تعال نشوف الجزئيه اللي تحت. هنا بيقول لي كربون 14 is radioactive with a half life of الكربون ده ربنا يديك العمر يعني. بعد وفاه اي بني ادم بيتحول الكربون، بدل ما بياخد او بيعمل ريسيفنج للالفا والبيتا والجاما بيعمل ايميتنج للالفا والبيتا والجاما. وده السبب اللي بيخلي احنا نقدر نعمل ديتنج لبقايا الكائنات الحيه اللي بنشوفها. يعني اقدر عمرها اقول لك والله التحفه اللي قدامي دي عمرها 7000 سنه او عمرها 5000 سنه من هنا. فبقول لي الكربون 14 is radioactive with a half life of 5700 years. An animal bone is like up in an archaeological excavation. ماشي. Anyway, the quantity of carbon in the bone is 25% of which it was when the bone was burned. Calculate the time that has elapsed since it was burned. طب ما ده سؤال بايظ يعني. يعني هي اتولدت من كام سنة أو how many years back، وهو بيقول اتس ناو، يعني هقول لك ايه، هي دلوقتي 25%. تعال نعمل نفس المبدا. ال 100 divided by 2 هيديني 50. طيب وال 50 divided by 2 هيديني 25. Now I reach it from 100 to 25. How many half lives passed? Twice. ادي الهاف لايف الاولانيه وادي الهاف لايف الثانيه. فهقول له كده number of half lives is 2. ده معناه بقى انه ده عمره كام سنه؟ اروح اقول له والله انه the age او التايم، خلي بالك عمره يعني فات، في اللي فات ها، تايم عباره عن الهاف لايف الواحده ب 5700، يبقى التايم كله على بعضه عباره عن 2 times 5700. فده هيديني 0 0 4 11 years. من 11400 سنه الكائن ده كان عايش. ماشي.
ماشي يا مستر، شكرا.
في حد بعت حاجه تاني، بس خليني اشوف مين. احمد، انت معايا يا احمد هنا؟ احمد بي، احمد باشا، احمد بي بدوي. خلاص يا اولاد انا هقفل دلوقتي حالا، بس خليني اقرا السؤال الباشمهندس ده. بقول لي هنا how is C and D not decelerating. فين C and D؟ ما هو C يا ابني the speed is constant، D the speed is zero، مفيش decelerating هنا. هو decelerating حصل ما بين C to D. هو ده السؤال. between A to B it's accelerating، between B and C it's constant speed، مفيش acceleration. إذا كان سامعني يا أحمد يعني. between C and D it's decelerating from C and D. It's decelerating. نعم.
مش هو مديلك ويردز كده لازم تستخدمهم، صح؟
مديني ايه يا حبيبي؟ الفاظ لازم استخدمها. مظبوط، ماشي. طيب خلينا نقولهم من الاول. هستخدم دول. لا انا عرفت الغلطه جت منين. بص احمد باصص اسمع له ايه. هو كاتب هنا C and D constant acceleration. ايوه يا حبيبي، ما هو deceleration بس constant. هو احمد عايز يكتبها decreasing acceleration. لا هو مش decreasing acceleration يا حبيبي، ده straight line يا بابي قدامي. وما دام straight line يبقى الاكسلريشن سواء بوزيتيف او نيجاتيف هو constant. فممكن اقول constant acceleration، بس صحيح الاكسلريشن نيجاتيف، فانا ما اقدرش اختار كلمه decreasing acceleration هنا. خلاص؟ فانا هقول هنا from A to B it's increasing. لا ده decreasing acceleration. فين هنا؟ decreasing acceleration from A to B، لانه بيقل، السلوب بيقل.
وحضرتك عامل شير للبتاع؟
لا انا مش عامل شير، انا بعتبر ان هو ان انتوا شايفين معايا على الجروب بتاعي. خلاص ثواني اعمل شير. فاين. بيقول هنا a bus is traveling between points A and D. There are bus stops at A, B, C, and D, but the bus does not stop at B and C. واضح. Figure 1.1 is the speed graph of the bus. خلاص شايفين؟ يلا كده نعمل describe للموشن between this، وهستخدم الألفاظ اللي مكتوب. يلا بينا كده from A to B. خد بالك إنه by the beginning نعمل edit بس. قلم. Okay. By the beginning of that هتلاقي إنه هنا we have a slope, so this is an acceleration، وهنا we have a smaller slope. في عندنا smaller slope هنا. خلاص؟ So we have less acceleration. فمعنى كده it is decreasing acceleration. The acceleration was more down and it becomes less. So I'm gonna choose here decreasing acceleration اللي هي دي. صحيح هو positive بس it is decreasing لأن السلوب is decreasing. So this is number one. Between B and C the speed is constant. يبقى ده zero acceleration. خلينا نشوف moving forward at a constant speed. انا موافق على دي على فكره. يبقى هي دي moving forward with a constant speed لانها constant speed 40 لا بتزيد ولا بتقل. from B and C it is 40. So I'm gonna write here it's moving forward فين هنا at a constant speed. اهي. So this is 2. تعال نشوف بقى between C and D. صحيح ده deceleration بس constant. انا ما عنديش constant deceleration بقى. فبرضه هي constant acceleration بس نيجاتيف. فهقول constant acceleration this is number 3. ايه المشكله فيها دي؟ صحيح ما هو النيجاتيف constant برضه. اللي اتلخبط هنا اتلخبط انه عايز يقول لك decreasing acceleration. هو مش decreasing يا بابا. ده هو اهو الاكسلريشن اهو acceleration اهو constant بس نيجاتيف. هقول له هنا نيجاتيف acceleration بس constant. يبقى الاليق ليها constant acceleration. صحيح it is negative بس written انه it is constant. So I'm gonna choose constant acceleration for C and D. بس كده خلاص. اتمنى الكلام ده يكون مفهوم واسف طولت عليكم وبعضكم زهق بس يعني معلش هم اليومين دول اللي بنتعبهم يعني.
لا شكرا لحضرتك كمان.
يلا كل سنه وانتم طيبين.
شكراً.
خلوني اسمع بكره لو في اسئله تاني اشرحها على الجروب وان شاء الله بعد الامتحان بعد بكره يعني ابعتوا لي كده طمنوني وقولوا لي ايه الاخبار بتاعت الامتحان. اخبار
تمام.
شكرا مستر. مع
يلا يا ولاد. Thank you. See you.